Hello. Today we will see how to split a data frame into train and a test set for machine learning tasks. The data frame that I am using is downloaded from this website, and my reference is based on the book Hands-on Machine Learning with Scikit-Learn and TensorFlow. So you can download the housing.csv file from this link. So, and I have in my in my working directory, a file called housing.csv. So now I'm going to import pandas spt, maybe a little bit more, and I'm going to read the data into the data frame pd.read csv and housing.csv. If you want, you can also refer to one of my previous YouTube videos on how to download the data using Python. You could do manually, or you can write a script to do that, which will be especially useful if the data is being updated, and then you don't have to keep on doing. You can automate that process. So this is it, and we read it. So this is my data, so we can scroll up and see. So we are going to split into two parts, a test set and a training set. So first, if you look at the length, this is the length of the data, and let us say 20% of the data we keep for the test set. So I can now construct say test length will be, I say 0.2 times length of df, and that would be, of course, a floating point number, so we can cast into an integer, and length. So that is that many lengths. So now I'm going to import numpy as np, and we are going to use numpy permutations we have total length of the data frame is 2640. So we are going to have that many a set, an array of one-dimensional array of that many lengths with the random permutations. So I tell you what I'm doing. So numpy, I say random indices. I say numpy dot random dot permutation, and the length I want is length of df. So this, if you look at this, is an array of different it gives you all the numbers from 0 up to 2639, and they are in different orders. Now the beginning number is 3725. Now I have my test length be 4128, so I need to break this random indices into two sets, one for the test and one for the train. So I can say test indices equal to random indices. I'm going to take from beginning to up to how much you want, test length, up to 4128. So if you look at, so we get it picks up the first 37259594 and so on up to 4127. So and now I can also make a train set, train indices equal to random indices. I'm gonna the rest of them. I'm going to index the rest. So from test length to basically 4127 onwards the rest. And I can also look that. So it picks up from wherever we left off and to the end. So now we have both indices. Now we have to just break our DF and just index the DF and construct both train and test set. So train we call it as train DF, or we can say DF train, DF test first. We can see basically we take DF dot, we use the log function and we index it. The log we have to get it's the test indices. So DF test, if you want to look, so we have say 4128 rows, so we have broken that down. And similarly we can also create train, and this will be train, and we also get the rest. So we have constructed the train and test DF. Now the thing is, we would like, suppose if we keep on doing the what we called as the, if I scroll up, if I use this line random indices, if I run this code again and again, I am going to get the random indices differently. And then when I break it up, I'm going to different indices because their order keep on changing since it's random. We are getting a random permutation every time, which means that test set, if you run this for many times, your script, the test set will keep on changing, which you don't want to see the test set all the time, because then that will introduce bias in your analysis. So in order to avoid that, what we can do is we can save it. We can make the object persistent. We could use import pickle. We can use the pickle and use object persistence. We can save it on our disk and recall them. In that way, both your test and train set will be remain the same throughout. So I can just say, for example, I create pickle and I say pickle dot dump. I need to say which object, say test set. For example, I just show you the first object, and I need to specify the file, and it has to be in the binary format. For example, I say I would say this is our def test set and maybe you can put, I just create August 2020, some name, or 2 or something, and PKL, maybe just an extension. And this has to be open for writing in a binary mode, and I need 2 braces. So I save that thing. And now if I say df, if you want to look, now it is already saved there. So now you can say df dot test recall. I can say, look at it, pickle dot load, and I say just put this stuff here. I need to, of course, change into read, and also I have to change read in a binary form. Now you can just df test recall, so I get that back. So similarly, you could also use for the train set. So in that way, both test and train set will be remain same throughout your analysis. Another way is when we created the NumPy, the random indices, this one, if I use that before, if I say now, if I just print, you get this again, you get a different thing. So we can avoid that. So we could, before calling random indices, if I specify a seed for the function by saying numpy dot random dot seed, I pass in a number. 42 is the magic number that everybody uses. So we can say numpy dot random dot seed 42, and so then what happens is that, and now let us try. I call this, and then just try to print it. I get this. Again I call, of course I need to make sure that we call that random seed thing every time you have to pass before we call. And then again I do the same line. So you see that this is identical to this. It doesn't change over the run. In that way, when you write the script, every time you use your test set and train set will remain the same, and you won't see ultimately all, if you keep on running, ultimately you will see all the test set otherwise, so which you don't want. So the idea is very simple. Basically we created NumPy random indices, and we broken down according to how many length we use, 20% for test set, and then we broken the random indices, and then we just index the df in test and train set. And you can use pickles for object persistence, or you can pass a random seed so that you see the same test, or you can keep the test set fixed rather than keep on changing it and introducing any bias in your machine learning analysis. So that's it. Thank you.